Okay, so we're going to use the quadratic formula. To use the quadratic formula, there's all kinds of A's, B's, and C's in it, so we're going to need to identify what those are. We cannot identify A, B, and C, though, until what? Until it's in standard form. That's right. So when it's in standard form set either equal to y or to 0, then we're ready to identify A, B, and C. So I told you to go ahead and identify A, B, and C. Was it in standard form ready for you?
Yes.
Okay, so what is A? 1. B is -4, and C is 3. Okay, so we're going to substitute into our quadratic formula, and you're going to write it enough. Every time you're substituting, you're going to be saying to yourself, this is what I'm doing. The quadratic formula starts out x equals the opposite of, or in other words, negative, and we're going to substitute in our b value, which is -4. And notice I put it in parentheses. My reason for parentheses is so I can see that I have a negative, and we're going to take the opposite of it. We really have two negative signs going on here. Plus or minus, because when we take the square root of something, if it's a positive number, it's going to have both a positive and a negative square root, so we have to account for that. And then under my radical sign, which is going to be a huge one, because you know how much it took you to do the discriminant, we have to do the discriminant now, which is b squared. So -4 has to get squared, and we're going to put that in parentheses. And then guess what else I'm going to do? Make that into a plus a -4, yeah. Did I not do that in the discriminant notes for today? Didn't I show you that we should probably, because if they don't go well, that would be the reason most likely, is because of that subtraction. So if we change it to plus a -4, we always work with it as a -4. And then we take it times our a value, which is 1, and then we take it times our c value, which is 3. So that, you know, sometimes you even have to extend your radical sign even a little bit more if you didn't make it long enough. So all of that is in the numerator. We need a fraction bar, a long one, all the way underneath that numerator. And then we have this basic, simple little denominator. What is it? 2 times 1, 2a. So we have the opposite of b upstairs, plus or minus the square root of the discriminant, which is b squared minus 4ac, also known as b squared plus a -4ac. All of that divided by our 2a. So now we're going to just do some cleaning up here. X equals, what's the opposite of -4? 4. Positive 4. Plus or minus. We're not going to get rid of that radical sign yet. Don't try and do too much in one step, or this quadratic formula will get ugly with you. What's -4 squared? 16. Plus -4 times 1. -4. -4 times 3. -12. Fraction bar got a little shorter. Just like our radical sign got a little shorter. And 2 times 1 is 2. Okay. Do not do too much in one step. Notice how much room I gave you on this paper to show all this work. Okay. So the next thing we're going to do is we're just going to take care of that radical. So 4 plus or minus 16 plus -12. 4. Positive 4. Okay. Over 2. So we did one thing. We simplified what was underneath the radical sign. 16 plus -12 became 4. Now, we're going to get rid of the radical sign next. 4 plus or minus 2. Square root of 2, and this takes care of the positive and the negative square root right here. So we just need a 2 there, and then we need a 2 downstairs. Now, remember when, this is really no different than when we were solving by using the square root method. And we had maybe something like x plus 3 equal to a positive and a -5. Remember I told you to break it into 2 problems. Don't just assume that you can get one answer and the other one will be the opposite. Same goes here. We're going to write this as x equals 4 plus 2 over 2, and x equals 4 minus 2 over 2. 4 plus 2 is? 6 divided by 2 is? 3. There's one solution. 4 minus 2 is? 2. 2 divided by 2 is? 1. X equals 1. They're not opposites of each other, are they? Okay, we'll grab a graphing calculator. I'm just going to set that on the board for you to have it. Help your neighbors out. We'll grab a graphing calculator. Let's see how we did. Because we find the solutions, we also found the what? What's another name for solutions?
Zeros.
The zeros of the function, which means what then on this graph? This is where the graph should what? Cross the x-axis. If you cross the x-axis at 1, it should cross the x-axis at 3. Okay, so good news is it's already set equal to 0, right? So that 0 can be replaced by what again? Y. So we're going to go to our y equals screen, clear out anything that's in there. We're going to type in x squared. X key is next to the alpha key. The x squared key squares that. Subtract 4x plus 3. Let's do a zoom 6 just to make sure we get a nice graph. Zoom 6 for this one. It looks like what? Looks like it crosses at 1 and 3. Okay, how can we verify that it does? Second graph, go to the table. Or we could do second trace, yes, that's another place we do it, but we could also just go to the table, and where x is equal to 1, y should be equal to 0. Where x is equal to 3, y should be equal to 0. Okay, did we do well? Okay, let me just plant this little seed right now. I just want you to remember this. When you use the quadratic formula and you get integer values, this was factorable. This would have been one we could have solved by factoring. We could have used our diamond method. We could have named it as a factored quadratic, set each factor equal to 0 and solved, and we would have gotten the same solutions. So just remember what I said at the beginning, quadratic formula solves any quadratic function. You don't have to worry about whether it's factorable or not. You do not have to worry about whether it can be solved by the square root method. Because not everyone can. But everyone can be solved by the quadratic formula. But this one also could have been solved by the factoring method. Okay? Not by the square root method, but it could have been solved by the factoring method. Okay, anybody have any questions? Or I said to Luce to try the next one. Okay, go ahead and write the quadratic formula. You got it memorized already, right? Go ahead, write that quadratic formula at the top of your paper there. I started it for you. X equals, up in the white space, write the quadratic formula. See if you can do it from memory yet. Trust me, the day will come and you're going to be able to do it for the rest of your life like I did. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Okay, is the next one, the other one that we're going to solve today, is it ready for us to identify a, b, and c?
Yes.
It is. Okay, go. Make it happen. Then the only thing I want you to do next is I want you to do the substitution step into our quadratic formula. quadratic formula. The only variable left should be x. Okay, after you've done your substitution step, would you check on mine for me, please? Here. A good habit to get into is just use parentheses for around every substitution you make. Just use parentheses. Whether the number is negative or not. Just helps you see where you did the actual substituting. Okay, how about you? Do you feel like I did a good job? Okay, where'd the 1 squared come from? In the quadratic formula, what's the first thing under our radical sign? B squared, right? So that's where that came from. Anybody else? Okay, then we're ready to move on, huh? Okay, so again, we're not doing too much in one step. We're not going to learn right now how to put everything into our calculator at one time, because trust me, I'm not sure you can handle all of the variety of parentheses you have to use. So the opposite of 1 is negative 1, okay? 1 squared is 1 plus, what's our 4AC become? Negative 4AC becomes 80. Negative times a negative is a positive, and then we have another positive we're multiplying by, so we end up with a positive, and 4 times 2 times 10 is 80. And downstairs we end up with 4. Okay, that's all we do in that step. We take the opposite of our b value, we square our b value, we do our negative 4ac, we do our 2a. Next, we say, okay, now I'm going to simplify my radicand. It should become 81. Then I'm going to take the square root of my radicand if I can. What's the square root of 81? 9. Okay, so that's going to become plus or minus 9 over 4. You do not get to do this. Trust me, it's going to get you in trouble. Do not say, oh, I got negative 9, negative 1 plus 9. What is negative 1 plus 9? 8. And then 8 divided by 4 is 2. So then you're going to say x equals 2 and x equals negative 2. The opposite. Is that what happened in the last one that we did? No. So let's see if it does on this one. Remember, we break it apart now into 2 problems. We have negative 1 plus 9 all over 4. And we have negative 1 subtract 9 all over 4. Yes, Cody?
Is it 9 perfect square?
No, 81 is a perfect square. And that's why we got 9. But 9, we are not taking the square root of it, even though it is a perfect square. We got rid of the radical sign. So no reason to take the square root of 9 also. We only need to take the square root of our discriminant. Our discriminant was 81. Okay, so negative, we've already decided that this one, negative 9 plus, or the negative 1 plus 9 is 8 divided by 4. We already decided that one's 2, didn't we? And negative 1 divided by negative 9, or divided by, negative 1 subtract 9, negative 10. What's that equal?
2 of them. Negative 5.
Yeah, negative 5 over 2 or negative 2 1/2. You can give it either way. Doesn't matter. Okay? You can give it either way. Okay, now let's go on our calculator and check ourselves out on this one. your y sub 1, clear out the one that was in there, type in your new quadratic function. You should be able to just press graph this time. It should already be ready to give you a good graph. This would be one of those times that we probably, if we don't want to make our table go by halves on the x's, we might want to use the second trace so we can calculate an x value. So we could calculate, we could put x equals 2 in and see if we get y equals 0. Remember how to do that? Second trace, and then I think the first command is value, right? Press enter, type in 2. And it should give you case. Oh, you don't. Okay. Are we right? Did the graphing calculator verify that we are right? Otherwise, we could do check problems. So now you take what we think the solution is, so 2, and then press enter and see if it shows the y equals 0. Yeah, you get that? Okay, now let me plant a little seed here also. Even though they are both integer values, because they are nice numbers, in other words, -2.5 is still a nice number, we could have factored this one also. We could have solved by factoring. This was one though where a was not equal to 1, so it would have been a little bit more work to solve by factoring because we would have had to use the diamond method and then the factoring by grouping. And then we would have got our factor name. Then we would have set each factor equal to 0, and we would have gotten these two solutions. Now, I want you to tell me why we got 2 real solutions for both of these problems that we worked. What's positive? It is because something's positive. What is it, Noah? Not because the a value is positive. That's not the reason. Devontae, sit up, and that will help. Could you help us out here? We're trying so hard to figure out why both of these have 2 real solutions. And Julia said because it's positive, and she thought maybe it was because it was the a value. And then Noah said, well, it is because it's the a value is positive. And I said, no. But it is because something is positive. And it's not your Monday morning attitude that I'm talking about. So, the b value is positive. No, that's not why either. Abby. Oh, what's that radical inside of the radicand called? The discriminant. Because both of these had a positive discriminant. What's the discriminant in this one on the back side? 81. It's right here. Here it is, right here. There's our discriminant. It's 81. It's a positive number. We ended up with 2 real solutions. Let's go to the front side. What's our discriminant? 4 is our discriminant in this one. A positive 4. We got 2 real solutions, didn't we? Okay. So, memorize this quadratic formula. Use it to get your answer in your homework today. You can get started on your homework. Yes?
If that 4 was negative, would it just be like?
Yeah, then we're going to break down. We'll get to those today. We're going to, once you practice today, they should all work out for you, okay? The discriminant should not be a negative. Anybody else have any questions? Okay, so you can keep the graphing calculators at your desk for a while if you want.